Oh, you're here. All right. Okay, so here we go. A ball is thrown straight upward and rises to a maximum height of 16 meters above the ground. Okay, so we know it's gone up 16 meters above the ground, above its launch. At what height above its launch point has the speed of the ball decreased to one half of its initial value? Okay, first of all, we know the acceleration. All right, we know um, the acceleration. So, and we know the distance that it went. So can we? This one's a little. There's a little nuance here. So I know the distance y since we're in the y-axis. The initial is 0. The final y is 16 meters on its way going up. Okay. Okay. So, and I know the acceleration is equal to 9.8 meters per second squared negative because it's g. Okay, because we're looking at. So now, is there a way I can find the initial velocity? Is there a way I can find the initial velocity? I think so. Because the initial velocity I don't know. Because when it's at its maximum height, what's its final velocity? When it gets up to 16 meters, at 16 meters, what's the final velocity? You're right. It's equal to 0. Okay? All right. Um, yeah, because and then I don't know the time. So um, so hey, I know this guy, I know this, and I know this. So here we go. So here's what we do. We go, okay, well, then V final, 0, is equal to V naught squared minus 2 times 9.8 times 16 minus 0. Okay? So we've got 0 is equal to V naught squared minus 19.6 times 16. And what I'm going to do is add this term to both sides. And so I wind up, that goes away, and I wind up with 19. This is nice. 19 times 16 is equal to V naught squared. I got a nice positive number. All I got to do is find my calculator wherever I hit it, and I've got my initial velocity. Is 19.6 times 16 square root of 313, 17.7 meters per second. Pretty fast. That's the initial velocity. Okay, so I can figure out the height that it reaches. There's two answers actually. There's two answers. I can figure out the height when it is equal to half of its speed, initial speed. And here's how I do it. I'd say, okay, so if V naught is equal to 17.7, then V final that I'm looking for in the new problem, so I got kind of a new problem. I go, okay, is equal to 1/2 over 2. All right, so take that divided by 2. 8.85 meters per second. All right, I know the acceleration. What was I supposed to find? At what height? Okay, so I got to find the height. So I got to find the time that it took for it to get to here. Or actually, some of you go, wait, can't you just do this? 8.85 squared is equal to 17.7 squared minus 2 times 9.8 times y final minus 0. Yeah, I can do that. That'll work. And I'm not afraid of it because even though I wind up with this is going to be a negative number, is equal to, see, because I subtracted this from both sides, is equal to minus 2.2 times 9.8 times y final. hey, this isn't any big deal because this is going to be negative, so I'll just figure out what that is. And I wind up with, I divide by negative 19.6, and I get a negative, sorry, I'm doing a bunch of stuff in my head here. I'm kind of hurrying because this has gone on too long. 8.85 squared minus 17.7 squared, negative 234, divided by negative 19.6 gives me 11.98. Okay. However, it reaches half its velocity in two different places. It's at 11.8 meters. Now this is, remember I said, Mother Nature loves symmetry. Okay? Mother Nature loves symmetry. So it at 11.98 meters, it reaches half its velocity. Let's look at it coming back down. So when it's coming back down, it's starting off V naught equals 0. And then we want to figure out, well, how far did it go when it equals 8.85 meters this way? Whole different ball game. This time I've got 8.85 squared is equal to, this is for coming down. Hold on 1 second. Is there a way I can stop? I've always wondered if I could stop the thing, but I can't. Okay, I'm going to have to come back.